here you have f of s equals 2s plus 1 divided by s plus 1. You're asked to state the Laplace transform of e to the negative 2t f of t. Alright, so let's look at this here. Remember now, you would have had an f of t before. Then you find the Laplace transform of f of t is what we call f of s. We have f of t, f and t are both lowercase. F of s, both f and s are uppercase. Alright. And that happens to be 2s plus 1 divided by s plus 1. Okay, good. Now you have e to the negative 2t f of t. And you need to find the Laplace transform of e to the negative 2t f of t. Okay, good. Now what is that going to be? Now notice the only difference between this and this is that this one is multiplied by e to the negative 2t. Now let's look if our formula sheet can help us. Formula sheet. Okay. Alright, now let's look at this. If we find the Laplace transform of 1, we have 1 over s. So the Laplace transform of 1 is 1 over s. Then we have the Laplace transform of e to the at. The Laplace transform of e to the at is 1 over s minus a. Okay, now remember this is the same as 1 multiplied by. Let's put this on the left and say e to the at times 1. Alright, so we have a shift here of negative a, or of a. Now this is called the first shift theorem. Remember that? So all we need to do now is say that the Laplace transform of e to the negative 2t f of t is equal to, it's going to be f of s minus a. Right? So it's going to be, you have 2s plus 1. In this case, it's going to be 2s minus a plus 1 divided by, you have s, in this case it's going to be s minus a. I'm going to change the a, you know, s minus a plus 1, s minus a plus 1. Alright, now here is s minus a. But our a is what? Is negative 2. So here it's negative 2. Or what we could do, instead of erasing it, let's rewrite this. Since we have this already, let's put this as a, and then we find out what is the Laplace. Let me put it lower. What is the Laplace transform of e to the negative 2t f of t? Is going to be, now look at this, we have the Laplace transform of e to the negative at f of t is f of s minus a. So the Laplace transform, in this case our specific f of t, involve negative 2. So here we have 2 s minus negative 2 plus 1. Alright? Remember, this is a general statement here. Is s minus a. So what we have is 2 times s minus a. In our case, a is negative 2. In this case. So here, plus 1 over. And then we have s minus a, which is negative 2. And this is s minus a, which is negative 2 plus 1. Alright. So, here now, what we do is see if we can simplify this thing. So this is 2 times s plus 2 plus 1, because s minus negative 2 is the same as s plus 2. Oh, the 1 should not be in the bracket. The 2 is only multiplied by the s minus negative 2. Alright, over s plus 2, and that's multiplied by s plus 2 plus 1. So, what does that give us? It is 2 times, well, in this case, it's 2s plus 2 2's 4, 4 1 5, over s plus 2. This is s plus 3. S plus 3. Okay, good. So remember now, we have our f of s being this. Just to review, we need the Laplace transform of negative e to negative 2 f of t. Now, this we have here would be a Laplace transform of f of t. Right? So here now, we need the Laplace transform of e to negative 2t f of t. And we see from the formula sheet that when we have e to negative, when we have e to the at multiply the function, the Laplace transform will be a function of f of s minus a. No longer f of s, but f of s minus a. So here now, we apply it to this. We change s to s minus a in this case, or a is negative 2. So we change s to s minus negative 2, simplified, and this is what we get.